So the cloud, I mean, it's sort of stating the obvious, but the cloud is awesome. But the cloud also has some challenges. And a lot of businesses find, and a lot of us as developers find, that when we make that shift from not cloud to cloud, we imagine it's all going to be sort of fluffy clouds, but instead it's clouds with lightning bolts, and we get electrocuted, which is a little bit unfortunate. So because of the shift to cloud, there's a whole bunch of skills that we didn't used to need. Whoa. That was the this is, see, chaos, it's perfect. There's a whole bunch of skills that we need in 2022 that we didn't need before. The first one is hand washing. I have never washed my hands so many times in my life as I did in the last 2 years. But then there's some ones that are sort of professional skills. So apps, I think probably would, hands up. This is so exciting.
Go over that side.
That side? Yeah. Okay, yeah. Yes, they said, where are you going to stand? And I already forgot where I said I was going to stand and moved to the wrong place. So hands up if you would consider yourself an app developer. About half the hands. I'm super interested what the other half of you, backend, or well, I guess backend is apps. What would you, someone who didn't put their hand up, what would you say your job is?
I'm a cloud engineer. I'm a cloud engineer.
Cloud engineer. So sort of more like infrastructure side?
I'm not a developer.
Oh, you,
I'm just interested in Java.
Ah, okay.
Not professionally yet.
Yeah. Got it. But when we do the apps, of course, now, you know, it's not enough to sort of write an app and have it running on our laptop and that's job done. We need to be thinking about that bigger life cycle of it, like how does it get from my laptop to production where someone uses it? You know, what's that ops side? And it used to be that the development side and the ops side were completely separate. But now we kind of need to know what's going on with that, which is DevOps, and that is a good thing. But of course, the problem with DevOps is when you look at DevOps, you sort of say, well, that's very nice that we have developers and operations talking to each other, but shouldn't we maybe think about security as well? So then we get DevSecOps, where we sort of say, we can't, security is too important, we can't possibly leave it out of this description. And then from there, we can go further and you can say, but what about the business? The business is the reason that we're doing this whole thing. So then you get DevSecBizOps. And you can just keep going like this for as long as you like. And I'm not going to go through, and then there's DesignOps, and I'm not going to go through all of them. But there is one that I want to talk about, which is FinOps. FinOps, hands up who's heard of FinOps? One hand. So yeah, FinOps is new. I think FinOps is going to be not the main part of our jobs, but I think we're going to be looking more at FinOps in the future. So I'll come back to what FinOps is. But with all of this, it's a lot, right? Like we used to just code, and now we need to do all of these other things, and we need to make it work on the cloud, and we need to keep up with whatever the latest cloud trend is, which is usually the opposite of whatever the previous cloud trend was. So I want to talk just a little bit about a few things that are different in the cloud. And I sometimes feel like this is just the wrong talk for 2022 because we've been using cloud for so long that we really should all have a handle on it. But the thing is actually, even though like, hi, I'm Holly Cummins. Let me tell you that technology changes fast. You know all that already. But even though we all know technology changes fast, even though we've been using cloud for 10 years, I think we're actually still pretty bad at cloud. And I think it's taking us quite a while to catch up with some of the things that are different in the cloud. And I think it's taking our employers a very long time to catch up with some of the things that are different in the cloud.
Every clinical trial starts with a question. At Teckro, we asked, why is it so complicated to run clinical trials? We asked, what if? What if you could see who is interacting with your study in real time? What if you could be certain site staff always had only current, approved documents? What if you could proactively implement improvements based on site feedback? What if you could deliver tailored messages with the right information at the right time for the right people? We transform your paper protocol into a digital hub of communication and collaboration. Teckro is a single cloud-based platform that provides all study stakeholders with the knowledge they need when they need it, even at the point of care. Today, Teckro is used by large pharma and emerging biotechs to manage trials around the world, supporting all therapeutic areas, all phases, and any trial model. Simple, intuitive, and easy to use, there's no doubt why site staff around the world rely on Teckro, the hub for communication and collaboration. Study answers neatly in your pocket. Have a question? Teckro the answer. Visit teckro.com for more information.
So I want to start with maybe one of the, looking in the wrong way, sorry. Hello, internet people who I'm not looking at. Move that way.
Just the light is facing.
Got it, okay. Awesome. Right, so I want to start with, I think, probably one of the happy stories, which is tracing. So we don't call it tracing anymore. We call it observability. And then people who actually know what observability is get really annoyed and say that it was tracing, it wasn't observability, and could we please stop just using observability as a buzzword to mean anything to do with tracing? But I'm going to use observability as a buzzword to mean anything to do with tracing, because that's what everybody does. It used to be, when you had an application, it would run on a server and it would make some logs, and if you had a problem, you would go to that server and you would get the logs. The new way is you have your application in a container instead. And when that application has a problem and the container dies, where do you get your logs? Because they're not on the container anymore because the container died. So we have a problem. And then we just spin up a new application, but that doesn't help us get the logs from the dead one. So what we need to be doing is we need to be taking those logs, pulling them out to somewhere else that's not the instance that just died. And then that means that when we have lots and lots of applications, it's all okay and all the logs end up in the same place. But then we have a new problem, which is when we have lots and lots of applications, and to do anything means going across 20 different applications in 20 different containers, and something went wrong. And it's not obvious what went wrong, because if it was obvious, we wouldn't have let it get wrong in production. How do we even begin to figure out what the problem is? So we can take all the logs out and put them in together, but we need something else. We need correlations, we need stuff. I think this is kind of a solved problem now. I think we're in a golden age of observability. We used to have open tracing, which had a good name. Now we have open telemetry, which is newer and shinier, and use open telemetry, don't use open tracing. And I think the good thing about it is no matter what vendor you're using, they're going to support open telemetry. So you can have different things going on in the back end. You can have them going to your aggregation supplier of choice, and you're kind of more or less okay. Having said that, I always ask, who here is using open tracing, open telemetry, that kind of, yeah, we've got one hand. So this is the good news. This is the bit that we've got sorted out. And what I find is everybody has really good intentions, and we're not quite there yet.
Partnering with Amazon Web Services, Globalpayments is transforming our issuer platform to deliver innovative payment solutions at scale in a secure cloud-based environment. from enterprises to small and mid-sized banks, and from new fintech entrants to embedded payment service providers. We are bringing world-class capabilities like program management and banking as a service to new markets globally. At Global Payments, our unparalleled legacy of reliability, performance, and experience, combined with AWS's cloud leadership, will meet the increasing demand of a connected digital world. That's Global Payments. That's innovation that delivers.
So the good news is observability is fixed. The bad news is that only Tom is getting the benefit of it being fixed. And I think it gets sort of worse from here. So performance is another thing. Like, we've been working on performance since the first computer. This is something that we should really know how to do. But every time we think we've kind of got it just about sorted, the requirements change. So the new requirement for performance in the cloud is that memory footprint is money. You know, it's literally money. You know, you can see your AWS bill going out in proportion to your memory footprint. And startup time is money. And so it used to be that we worked really, really hard to make an application server that you could start, and then you could change the wheels on it and you could change the tires, and that thing would still stay up while you were busy replacing parts of it. And once a year, whether it needed it or not, you would take that thing down. So we worked really hard to build dynamism into these runtimes. Now, not only do we not need it, all that dynamism is actually slowing the application down, so it's hurting us. I used to work on a very dynamic application server, so it breaks my heart a little bit that all of the stuff we did is now worse than useless. But it's, you know, it's kind of true. This stuff was necessary when we kept things up for 6 months. It is not necessary if you're running in a container, because you're never, well, hopefully, when you have your application in a container, you're never going to be busy patching your application in that container. You just run the build pipeline again, get a new container, deploy that. And if that's not what you're doing, then there's some things that you need to fix. Another interesting thing that's changed is I used to work as a JVM performance engineer, and people would say, couldn't we just do ahead of time compilation? Wouldn't that make the JVM so much faster? And I used to have to say, no, ahead of time compilation actually makes it slower. You don't want to do that. 10 years ago, that was true. Now, that's a little bit true, but not really true. Because we don't need that dynamism anymore, it makes a lot of sense to kind of front load a lot of the work. And so we have to do our performance optimization differently, because the correct answer is different. So the way we get there is different. Garbage collection has also changed a little bit. I spend a lot of my time sort of going around saying, garbage collection doesn't slow things down as much as you think. It's really okay. Garbage collection pauses aren't hurting you unless you're writing a UI. But I heard this story from Martin Verberg of Microsoft. They were debugging a problem, and the latency was just horrible, and they couldn't figure out why. And then they worked out that they had about 100 microservices all running Java. And anytime a request would come in, it would go to the first one, then to the second, then to the third, then to the fourth. And so it was almost guaranteed that at some point on that path of 100 microservices, one of them was going to be doing garbage collection, which meant every single request got a garbage collection pause, which wasn't really what they were hoping for. So they needed to think differently about how they handled the latency, how they handled the things because of this. And more generally, just the JVM hasn't totally caught up with what we need it to do in the cloud and how we run it in the cloud. And my colleague, Ben, wrote this article with a sort of boring title, Best Practices for Java in Single Core Containers. But if you actually read the article, he found some quite interesting stuff. Because the JVM tunes itself differently, depending, it tries to guess what you're doing. It's like, okay, let me be a clever JVM and let me think, are you running on a server? Are you running, on the desktop? I will have different GC policies. I will do different things depending on this. But how does it decide if you're running a server? Ben looked at the code, and what he found is this. This is the actual OpenJVM code. Well, actually, it's not literally the code, but he found that if you have more than 2 physical CPUs and more than 2 gig of memory, you're counted as a server. If not, you're counted as not a server. Please don't behave like a server. And this is unfortunate because in containers, a lot of containers run with less than 2 gig of memory and with less than 2 physical CPUs because you're trying to pack these things really densely. And because you're doing that, the JVM has gone, you must be running on the desktop. Let me be optimized for that. I was like, no, I'm not running on the desktop. I'm running microservices. I have a lot of servers. Just because I have a lot of servers doesn't mean it's not a server. And it makes a difference. So Ben did a plot. And so he configured it to run either with 1 CPU or 2 CPU, and he looked at the GC pauses. And so the blue line is 1 CPU, and the orange line is 2 CPUs. And you can't compare exactly directly because one had twice as many CPUs as the other, but you can see that in the 1 CPU case, the GC pauses are 5 times as long as they were in the 2 CPU case because the JVM was tuned differently. That may not be what you wanted, especially if you have that case where you've got your microservices chained together and you don't want to hit a GC pause. So what do you do? The takeaway there is be aware that if you shrink your JVM containers too much, the JVM will start making some weird decisions that may not be what you wanted. But of course, if you're paying attention, you'll remember that I said in the previous section, you want to run your containers as small as possible because memory is money and all of that. So I think, leaving aside the beer that we spilled on the floor, this is actually the chaos part where you have to run your containers small because that's taking advantage of the cloud and that's the most financially efficient way to do it. But you have to run your containers big because otherwise your JVM will not do what you want. And of course, we're only just beginning. The next problem that we have is management. And by this, I don't mean your boss. I mean the management of the actual hardware. Because in principle, cloud made it so that we didn't need to worry about managing our hardware. It was someone else's hardware. But the problem with cloud is it makes it so easy to provision hardware. that doesn't mean the hardware is free. Someone somewhere is still paying for that hardware, and it's probably actually your boss, which means when I said this wasn't a problem about your boss, that wasn't quite true. Because the other problem is, so the hardware, someone is paying for that hardware. And there is no guarantee that hardware is actually even doing something useful. So many of us provision things and then get distracted, and then it's not useful. And in general, cloud providers have an incentive to help you provision software, provision instances. They don't have so much incentive to help you deprovision them. So there's not very much built-in capability to say, hey, by the way, do you want me to shut this off for you? Because it's costing you £2,000 a month and you're not actually using it. It will just keep going and eating up money until you manually go shut it off. And this happens like all the time. When I was first learning Kubernetes, I did what anybody would do, of course, which is I created a cluster. But then I had too much work in progress, so I got pulled away to something else. And then 2 months later, I was like, oh, yes, that Kubernetes cluster. And it was kind of a well-specified cluster. So it was €1,000 a month. So then that was sort of a slightly awkward conversation with my boss to explain why I'd spent so much money. And like that was kind of a big one. But like the other month, we wanted to build Quarkus on M1 in GitHub because we were seeing issues that only turned up on M1. And so I had to get a self-hosted runner, so I went to Mac Stadium and I provisioned an instance, and then I had too much work in progress and I got distracted, and 2 months later I went back and realized it wasn't as much, it was only €150 a month, but it was still this computer that was doing nothing, that was using power for 2 months because I was kind of busy. And this just happens everywhere in our industry. So our industry has a problem, which is known as zombie servers. And to get a sense of the scale of this, in 2017, some people went and tried to quantify it. And the good news is it's not just me who keeps doing this. The bad news is everybody keeps doing this, and around 25% of the servers they looked at were doing no useful work. And they were trying to figure out, like, how did this happen? And their best theory was perhaps someone forgot to turn them off. It's just, it would be funny if it wasn't kind of terrible. So this brings me back to FinOps, because FinOps is trying to bring some of those real-time techniques, trying to bring some of those data flow techniques that we've got used to elsewhere to finance, and particularly the finance of IT. So what FinOps really is figuring out who in your company forgot to turn off their cloud. And it turns out to be an incredibly hard problem. I've seen many techniques, and none of them are very good, and most of them seem to involve desperate emails of sort of, we've looked at our cloud bill and it's quite high for this month and we don't really understand why, and could everybody please look at their instances and see if they forgot to turn them off? Or when they don't get enough response to the emails, it's a meeting. So everybody sits there with the screen and they kind of go through, okay, instance A62, who owns instance A62? And then that doesn't work, so then we try and tag them so that we can track them, but that's manual, so then the tags, so it's a little bit of a mess. And it's potentially a life-threatening mess for some companies. So there's this new genre of internet horror stories, which is companies that nearly went out of business because their cloud costs had a bit of an accident. And there's a great one with a company. They were doing some testing and they deployed to Firebase, and they deployed on a Friday and then went home on for the weekend, as one does. And they came back on Monday and they went, why is our cloud bill $72,000? We thought we were on the free tier. But what had happened was they had an infinite loop in their test code. And I mentioned that companies tend to be very good at helping you consume and less good at helping you not consume. So AWS have refunded them. But what had happened was AWS went, you seem to be using more than will fit in the free tier. We'll help you with that by moving you up to a paid tier. And here's your $72,000 bill. And they were a little startup. They didn't have $72,000. So because of the publicity, it did all get sorted out. But it was nearly very, very bad. And this can happen to quite experienced people as well. How many of you look at Troy Hunt's haveibeenpwned.com?
I was really into science, and I kind of wanted to be maybe an astronaut or work for NASA in some capacity. We grew up watching Star Trek, Stargate, Red Dwarf, all these different programs. I think Stargate was probably the biggest influence because there was a female character in that was one of the main leads, and she was a physicist, and so it kind of made you think like that's possible as a female. So I went to uni and did physics with astrophysics for my degree, and then I decided to keep going with that, and I stayed in academia to do a PhD. Astrophysics isn't as far from software development as you might think. It's really about solving problems using mathematical skills and software development. I ended up being really more passionate about programming and solving problems that way than actually about astrophysics. I just started applying for jobs in Belfast for software development, and I found LibertyIT. They took people from a background in STEM subjects, so science, technology, engineering and maths. Liberty's focused on diversity and diversifying the workplace because they realise that a diverse workplace actually is better at problem solving and better at coming up with solutions for the customer. So my previous life as an astrophysicist might seem worlds apart from my career in LibertyIT, but the skills I learned just generally solving problems on a daily basis has really helped me in LibertyIT, and I've used it every day.
Yeah, about half of you. I saw him speak about a month ago, and I was so relieved because I've told this story lots and I never knew how to say it. I did do you say the owned or do you say pwned? But he says pwned, so now I will say pwned. So this is his cloud cost bill. And you can see that for most of it, it kind of goes along the bottom. And then over Christmas, it went up, and it was Christmas, so he wasn't looking at his cloud cost bills. He was like opening presents and eating turkey and whatever. So when he zoomed in on that to see what was up, he had an 11,000 bill for this service that he just runs as a public bill, as a public good rather. And so when he looked into it to figure out like what happened, how I thought I had this sorted out. Someone found a setting, and there was a setting that said, please cache this so that you don't get big data bills for the data in and out, unless it's over a certain size. In which case, if it's over a certain size, knock yourself out, send it back and forth every time. And again, I can't figure out why you would ever want a setting that says cache the small data, but the really expensive data, please charge me for. But that was the setting. So yeah, I found a setting to set the max cacheable file size to 15 gig, and it looks like, so what had happened to trigger it was his file size, his base data, had just crept over the limit for the cache, and it was being sent back and forth and back and forth. So it's all quite sad, and it's all quite stupid, really. So I think maybe actually this is the chaos part of just, this sort of uncontrolled cost because of stupid settings. Some things have, I think, got better though. So it used to be that releasing was very slow and very expensive, and you had to press things to CDs, and so you could only do it once every 2 years because that was so expensive. And so you would have your schedule, and you were going out on that day, and no matter what happened, you would go out on that day. Now, with microservices, we can release much more frequently. But the bad news is I think some of those habits that we used to have of we're going out on this day, and if the feature's not ready, then please work harder, please work over the weekend, that's still there. It's a little bit orthogonal, but I don't know if any of you have been seeing the photos of Twitter employees sleeping in their offices over the weekend as they work on new features. So there's sort of again, it is very much microservices, and yet there is this push to this new microservice is going out on this day, and we don't care if you have to sleep in the office. And again, this is just a really counterproductive way to do development, because if people are tired and if people are pushed to a deadline, they code slower and they make mistakes. So it doesn't help you, but it is what it is. And I think a lot of organizations, they still release their microservices, even though they're cheap to release. They still release them really infrequently because releasing is expensive, and because there's so much ceremony built up from the old way of releasing onto CDs, and we haven't got rid of all that process, even though releasing now should just be a push and it goes through a pipeline. So I used to work, as we discussed, I used to work for IBM, and I worked in a consultancy organization called the IBM Garage. And our whole mission was helping businesses take advantage of the cloud. And a large bank came to us, and their lunch was getting eaten by the challenger banks, and they said, "Oh, we're moving too slowly. We think we've figured out what the problem is. We've got all this COBOL. We need to modernize this, get rid of the COBOL, and go to microservices. Can you help us?" And we were like, "Oh, yeah, we can definitely help you." And then they added, and our release board meets twice a year. So at this point, it doesn't matter how many microservices you have. If you are only having your release board meet twice a year, that's going to be your release cadence. Every microservice is going to get released twice a year. So you may as well skip the overhead of microservices, because microservices can be quite expensive in terms of the observability and everything else, and just maybe stick with a monolith. But really what you need to do is fix this release situation first, and then once you've done that, go and look at the code. And I think we all want modular applications, and I think we sometimes assume that the way to get a modular application is microservices. But we had so many customers who would come to us and say, "Okay, so I really want you to help me get to microservices." "Okay, but what problem are you solving?" "Well, my problem is that I don't have microservices." "No, but really, what problem are you solving? Because if you want to release faster, or if you want to, different problems will have different solutions, and only some of them involve microservices. So really, microservices may be a means to do something, but they are not a goal in themselves. And I think often we go to microservices because we see the Netflixes do them, and we say, "I want to be like those companies." And that's fair enough. I think it's natural that we all want to improve ourselves. We all want to learn from people who seem to have it really sorted out. But I think we do also need to look at the context and say, are my problems the same problems as Netflix's problems? And I think as well, because cloud has become so associated with microservices, we sort of say, "Okay, I want the benefits of cloud, so I'm going to go to microservices." Well, no, you can use cloud really happily and successfully without microservices. And I think sometimes people say, "Okay, but I don't want to just do cloud. I want to do cloud native, so I have to do microservices." Well, no, you can write really beautiful cloud native applications that don't have all of their communication smeared out across the internet, and that's okay. Because microservices do have costs, and they do have problems. When I was a consultant, I was sort of parachuted into a troubled project, and I got off the plane, and they said, "Holly, every time we touch one microservice, all of the other microservices break. If you've been paying attention, you know the sort of the point of microservices. When people like the microservice salesman comes to you and says, 'Buy the microservices,' they say, and everything will be totally decoupled. You can change every service, no matter how much, you can do anything to it, and nothing else breaks." The reality is slightly different. And there's a name for this, which is a distributed monolith. So just because your communication uses the internet doesn't mean you're decoupled. And a distributed monolith is like a normal monolith, but it's worse, because in a normal monolith, your IDE is going to help you out. And it's going to say, hey, by the way, did you know that like you've just changed the type over here and all of this is breaking, so I'm going to refuse to compile. If you change your types on the internet, you can just deploy and you only find out it breaks at deploy time. The other problem that you have is if you're running in a single process, if you want to call another function, you just call the other function. That's the JVM's problem. You don't need to worry about it. If you're talking to your service over the internet, over HTTP or REST or messaging or whatever, it is your problem to make sure that you called it. So you have to write all of this sort of error handling logic to say, okay, well, I'm going to call you, but if you're not there, here's what I'm going to do. And if I call you, but you don't answer me back within 10 seconds, here's what I'm going to do. And it's a lot of work. So you need to think carefully about whether it's actually what you want, because you still very much can have spaghetti, even if you're microservices. And when I looked into this SAD project, what had happened was they had a problem with their domain model. So they had quite a complex domain model. It had like, about 70 classes and then, or 70 fields, and there was about 20 classes. And they said, well, we want to be decoupled. So we're not going to have a common library with this object model, which is, I think, maybe a reasonable decision. Instead, we're going to copy and paste the object model into each of our microservices, which was not such a reasonable decision, because it meant any time anybody changed one of the fields, anytime anybody changed anything in the object model, they had to then have a meeting and tell everybody else, hey, by the way, I've changed this. And this is definitely not how to do microservices. So the idea with microservices is that you have a whole bunch of services, and each service exactly has its own domain. I think this is maybe not totally realistic. I think you're never going to get that kind of super pure domain division. But what they had was this, which is definitely bad. So they had the same domain and they had stuff within it separated into different microservices. So it was, each thing did a different function, but the domain was exactly the same, which is why they had this massive, horrible coupling. And I think with microservices, there is this temptation to treat distributed and decoupled as synonyms and to say, hey, my application's distributed, so it must be decoupled. No, your application is distributed, so that coupling is going to hurt you much, much worse than it did before. Well done. And that, I think they both start with D, so it's kind of like, well, distributed decoupling, it's all okay.
In 2019, there were more than 5,000 data breaches. With Oracle Security, not only does it offer you greater agility, flexibility, and scalability, it also puts security first. Security that's automated, always on, and architected in, protecting data throughout its lifecycle and across the full stack. That's Oracle Security.
Okay. And there's other problems. There's not just the sort of, the type names problems, because sometimes behavior will change and that will cause breaks. Sometimes, in this case, every time they would change a field name, that would go into the JSON and that would cause a break. So that doesn't mean never do microservices, but it does mean that there's some sort of maturity things that you need to have well in place before you go to very granular microservices. So one is automation. You've just got to be good at automation. And the other one is testing. You've just got to be good at testing, and especially automated testing. So when I think about how much to test and where to test, I find it quite useful to think in terms of the test pyramid. So the idea with the test pyramid is at the top of the pyramid, you have your end-to-end tests. They're really good, but they're also really expensive, so you don't want too many of them. At the bottom of the test pyramid, you have your unit tests. Those are so cheap to write. They're so cheap to run. The only problem is that they don't necessarily give you very much confidence that your system actually works. Hands up who has had all green unit tests and totally broken system, right? Like all of us. Yeah, and then someone says, but the test coverage is 96%. It's like, yeah, but it's broken. I don't care what the test coverage is. I care that it's broken and my tests aren't telling me. So in the middle, sometimes people draw integration tests, but what I find most useful to have as the middle layer is contract tests. So hands up, who's heard of contract testing? About 3 hands. Okay, so those of you who've heard of it, hands up who's doing contract testing. 2 hands. Okay, so we're at about like maybe 10% heard of contract testing, maybe 5% actually doing contract testing. This is sort of consistent with what I see. So contract testing, I think some of us know we should be doing it, and then fewer are doing it. It is really worth doing. There is a cost to it to get started, and it can sometimes be confusing, but it will save your bacon. It is so good for giving you the confidence of end-to-end tests with the cost of unit tests. And a useful way to sort of think about what contract tests are doing is by thinking about how we test a fire alarm. So if I want to know my fire alarm works, there's a very reliable way that I can do to figure out if my fire alarm works, which is to take a large tin of gasoline and a match, and I set my house on fire. And if I hear this plaintive little beep, beep, beep from inside the house as I watch the smoldering wreck, I go, that fire alarm really worked. It did its job. But my house has just burnt down, so the fire alarm is the least of my worries. And you like, yay, confidence, but bad cost. And you kind of hope someone tests a fire alarm like this at least once, but I don't want it to be me. So the other way you can test a fire alarm is there's a little button on the fire alarm. And you go to the little button, and you push the little button, and it goes beep, beep, beep. That gives me really good confidence that if I push the button, the fire alarm goes. But I have never seen a fire kind of stroll through a building and then with its fiery fingers go, push the button, right? Fires have smoke, not fingers. So there's this sort of missing step of, if there's smoke, does the fire alarm go beep, beep, beep? And there is actually a way that this is tested. Anybody ever seen one of these? Yes, oh, hands, yeah, cool. Oh yeah, 4 of you. Sometimes I show this and people are like, what? What is that? I think I've only seen one once myself. You sometimes see these in institutions, and there'll be a little person, and they have, it's like a cup, and it's on a long stick, and they sort of wrap it around the fire alarm, and then it sort of goes psst, and it releases a little bit of smoke, and then the fire alarm goes beep. So it allows you to, it's not the same as a fire, but it allows you to test that connection that you care about, which is, does smoke make a beep noise? So in the happy case, smoke gets a beep noise. So I'm going to do a little demo of some contract testing. I'm going to show a contract testing framework called PACT, which I think is, well, yeah, it's the one that sort of gets most widely recommended. If you're only using Spring, you can use Spring Contract, but I think PACT is more capable, and PACT is polyglot, so it's quite useful for if you're running multiple languages.
Hi, it's Jerry Nolan here from Stack & Co. If you're stuck in your job, considering your next career move, or even just curious what the software engineering job market is like out there at the moment, reach out to me at Stack & Co. We'll have a confidential conversation, go over your career aspirations, your goals, and how to progress your career to get there. And if the timing is right for you, we can introduce you to some of the best software engineering career opportunities available in Ireland today. Reach out to me via our website, stackand.co.
Excellent. So what I've got is, when I started to write this demo, it was going to be a really elaborate demo, and I was going to have like 6 microservices, and then I realized that life is too short to be trying to stand up 6 microservices in front of people while the demo gods sort of rain fire down on you and stuff. So what I have now is I have the world's simplest microservices application, which has a front end and a back end. But the good news is you can still get not on the same scale, but things can still break even when the front end tries to talk to the back end. So you can still see the concept. So what we've got a little front end application, and then, which I will show you here. So here's my front end. And you can see that this isn't doing anything because I do not have a back end. So if I go to my back end and if I start up Quarkus, if I spell Quarkus correctly, then you should see I've got tests, I have an application, and if I go here, I will trip over my trousers. I have literally just tangled myself in my trousers. Which just goes to show, no matter how much you prepare your demo, something can still go wrong, even if it's your clothes attacking you. So you can see the model here. I'll just refresh so you can see, is that there's sort of some state, which is the person, and then they go through what was intended to be various services and is now just one service, which is the rooms of the house. And so as they go to each room, the state changes. So like when they go to the kitchen, the stomach gets bigger because they ate. When they go to the bathroom, then their hair gets smooth because their hair got brushed. And you can see then there's sort of, an insight here into the actual data model. But if I look at my data model, you can see I've used the word torso for the model. That, I think, isn't great. So let's just look at what's going on there. No, let's not do that. OK, so I'm going to change torso to be stomach. So if I go to my little front end, and I bring up, actually, I'm just going to do it with search and replace. So if I look for torso, and if I replace it with stomach, then I can replace all. And then if I run my tests, let me just do that again. Yeah, OK, all my tests are running. Let me just be extra sure, so I'm going to run my tests again. And all my tests are running. I go to my front end, my back end, and I rerun all my tests. It's incredibly annoying for demos. I don't know if you can see that slight flash is Quarkus running the tests. And the number of times I've gone, oh no, it's not working, it's not running the tests. And actually it's just that it's running them quite quickly. So I can rerun the tests, and they're all passing. So now if I go to my application, it unexpectedly works. Do you know what I did? So I have no idea why this is working, but I changed it on the wrong service. So I'm going to change stomach back to torso here. It's like there's the hierarchy of broken, isn't there? So the first one is it doesn't work. And then the second one is my tests pass and I don't know why. And then the third one is everything works and I don't know why. And that's when you're really in trouble. So what I'm going to do is I'm going to go back here and I'm going to go to the resident. And I'm going to change get torso here to get stomach. And so now I have done a successful refactoring. Yep, you can see tests ran due to a change in the resident. And so now, if I run my application, you can see I have a problem. Which is that I changed the back end. All my tests continue to pass. My front end tests will also be passing. And yet, actually, the connection between the two is broken. So how do I encode that connection between the two in code? This is where Pact comes in. So what I'm going to do is, PACT is an example of what's called consumer-driven contract testing. So the idea is that the consumer has responsibility for making the contract, for saying, this is what I expect you to do. And then you share that contract back to the provider. So I'm going to bring in one I prepared earlier. So it ends up looking, I defined some state. And I just defined some options. So I say that the hair can be frizzled or combed. I do it in code. And then I just run my tests. And what it's doing for the consumer is it's acting as a mock. So it's saying, when you run this test, I will give you back something that exactly matches what you've specified here. So it means that you don't have the work of writing mocks, because PACT is acting as your mock. So if I roll this back and bring it back in, then if I rerun my tests, what I should find is in here, if IntelliJ is very slow at refreshing, but in here, oh, come on, refresh. Does anybody know the trick to make IntelliJ refresh quicker?
It's right there, reload from disk in the menu.
Reload.
Right below Git.
Ah, thank you. There we go. So if I reload from disk, you can see I've got this contract which just sort of defines out a bunch of interactions. So it says I'm going to go to /resident, and I'm going to call get, and then I'm going to expect a 200 back with something that looks a lot like this, except that the hair can be frizzled or combed. So what I do now is I can copy that contract over to my back end. And on my back end, I will also bring back a test. And so you can see it's a very minimal test. All I have to do for the provider is say, look, this contract is over there, PACT, could you please make sure I meet that contract? So it's the easiest test you will ever write. And if I roll it back, and I've got my contract, then what you're going to see, Quarkus has what's called dev mode and continuous testing, so it will run the tests anytime something changes. Quarkus also does a lot of stuff with class loading to make that work. With PACT out of the box, dev mode doesn't work, so I have to run the old-fashioned way and do Maven verify. But if I do that, then what I should get is a red build. Yeah, so I've got something saying, hey, look, it was supposed to be torso, but instead I've got stomach. That's kind of weird. So this is good because it means that I have successfully got my test broken to reflect the broken reality. So that was a very quick tour, but hopefully that gives you an idea. Cool. So yeah, the sort of the takeaway is PACT will act as a mock for the consumer. It will act as a functional verification suite for the provider. And then you have that shared JSON contract to align the expectations. PACT is a lot more capable and a lot more powerful than just Open API validation. So Open API validation is another really good way of making sure that the two sides match up. But PACT can test actual behavior, not just, okay, does the syntax look like this? Does the shape of the JSON look like this? So for the total summary, definitely, even though we've been doing it for 10 years, don't assume cloud is a solved problem. It will continue to find new ways to make your job harder, which is kind of good because that's what we're all here for, is the problem solving. Don't assume microservices will solve all your problems. They may make your job harder. And contract testing, I think, will solve some of your problems while possibly also giving you new problems because that's what we're all here for, and that's our job. And so with that, thank you very much. The slides are there, and I think now we have pizza and beer.